according to this computer. Okay, so we're going to start looking at our first set of practice problems, which you're going to find in module number 1. And we're going to go down to module number 1, practice problems. Okay. Now, if we look at our learning plan first, just as a review, practice problems are always going to be done during class. It's going to be my thing to do with you. All right. It's going to be an introduction to the types of problems that you're going to be doing for your application problems, and then ultimately your unit assessments. So in class here, if you attend and you go through class, you will get all the answers. This is like the answer key. I'm going to be doing it for you, but you do it along with me. All right. So that you understand, how to do the problems and then what's expected. So that's practice problems. Connect is going to be, again, outside on your own. And it's going to be you kind of getting your nose in the chapter, but you're going to be doing this online. And that, again, those are worth 20 points. And you'll get all 20 points once you finish that assignment. It's not going to be a deduction if you get something wrong or anything like that. It's like you get all the points. It's like kind of like you do it or you don't. All right. Practice problems are 10 points. Okay. 10 points. And again, that's going to be on completion. So I'm going to look, did you do all of the practice problems? If you miss one, it's a 0. All right. You got to do all the practice problems. If you followed the format that I was doing here in class. I know with math, there's a lot of different ways to do things, but as we go through, one of the expectations when you get out in industry and as we go through to other classes is I've got to be able to follow your work to know if you did it correctly or not. Okay. You've got to document, you've got to be able to prove to somebody, I did the calculations and how I did them. All right. And so at times you're going to be sharing your work with other people. I need you to practice, being able to communicate written wise, in that manner. So I'm going to be showing you the things that I'll be looking for. And then the application problems, those are going to be the ones that, yes, those are going to be graded as well. And those you'll have a chance to make the corrections to. It's kind of like, like official homework, if you would. All right. Okay. So I'm going to go underneath my camera. Now, this particular chapter or this module is going to be just a little bit different than ones going forward. So you'll notice that it says module 1 practice problems here at the top. And what I've done is I've listed the practice problems for you. So you are going to do the connect, and it's going to be more concept related, some other, vocabulary and such. But this part is practicing, kind of warming us up to the math that we're going to be doing and applying in statics. Okay. So we'll talk about this in a little bit, but let's kind of review up here. So your 2 options for grades are either 10 points or 0. So 10 means you completed and done as demonstrated in the lecture, and 0 is either not handed it in or does not follow the formatting demonstrated during the lecture. It's a 1 chance hand in. So if you get a 0 on your practice problems, you can't make corrections to them. I only want to see them once. Okay, that's it. And that's how that goes, because you're given the answers here. I just feel like all you got to do is follow along. Follow along with the lecture demos for module 1. Work the following practice problems on a separate piece of paper. We're never going to try to fit them in down here. I don't care how small you think you can write. I don't want them on here, where they're going to be on a separate piece of paper. Be sure, and that's why if you don't print this out, that's okay. This is just giving you your problems. Follow along with all the, be sure to show the original problem and all the steps to find the answer. Put a box around your final answer. Use pencil. Use pencil. Be neat, and don't forget, if I can't read it, it's wrong. So even when you're uploading your picture, be sure that it's clear. Okay. One submission. And if it's not clear and it's blurry and I can't read it, it's a 0. Important note, this assignment is graded as completed or not completed. You'll be working each one of the problems below during our scheduled lecture demo times. To earn all 10 points, you will need to complete each practice problem, and show the formatting demonstrated in class by the instructor. If any problems are missing or formatting not followed, you will not earn the points. Now, this is an important note here where we see the asterisks, and it'll make more sense as we go through, but make sure, and this goes from this day until you're done with the program. Make sure that you write all original equations in an up-down, not a slash format whenever fractions are present. I need a numerator, denominator, top, bottom, not the slash. And the reason for that, it's going to become more evident later on when we do more equations and we have units. we can see unit cancellations, and we can see how if we end up with the correct units in a problem, we know we set it up correctly. All right, so top bottom format, and I'll illustrate that here today. So the problems we're going to be looking at are going to be here. So you're going to notice that on this set, and again, this is a little different. Most often the practice problems are going to be coming out starting in our module number 2, coming out of our textbook. There's going to be example problems that we work there. We're going to do those in class, but because of I want to make sure the math, they don't really focus on the math in chapter 1 in your book. So, so these are like separate for us on this piece of paper. So our first set is going to be 12 like algebra formula rearrangement problems. All right. And we're going to be going through those in just a bit. The next set is going to be 2 equations, 2 unknowns. I'm going to be showing you the substitution method. There are other methods that you can use for this, but we will be using the substitution method. So that's what we're going to be using for these. I'm going to be showing you how to convert units using the ratio method. All right. So, and most of you have probably hit these along the way, but that's going to be how we're going to be doing those. Yes, there are multiple ways of doing some of these things, but I'm specifying the way I want you to do them. And then set number 4 is going to be looking at rectangular components of forces. Okay. So, so we're going to start here with set number 1, algebra. So I'm going to grab a piece of paper from under here. All right. So as it states there above, it says you need to show your equation first, or start with the equation. Now, you'll notice that for step number 1 here, problem number 1, it says solve for V. You do not have to write solve for V. All right. What I want you to start with is this right here. Okay. So I'm going to, and the other thing that for you to be aware of as well, remember when you're handing in your homework, I know it's practice problems for module 1 because you're putting it in the right, place, the right assignment on Canvas. I also know it's you. So you don't need to add those 2 things to the top, but in this case, we do have a set number 1. And so I'm gonna just kind of start my heading here with set number 1, or set 1 algebra. And then down below that, I'm gonna start with like my number 1. So I'm gonna kind of start like this. And then that way, as I'm going through, I'll know, which area you're working on. So always kind of start that way. Now, if you don't put set number 1, do you think that I won't take points off? Okay, but just make it obvious. The other thing that I want you to do, pencils. Does everybody have a pencil today? Okay, always bring pencils, because that way, if you make a mistake, you can erase it and move on. And it's nice and neat when you hand it in. Okay. Additionally, do your problems in order for me. If you're starting with number 1, then I expect number 2, number 3, number 4, and so on. Don't like put things in and out. All right. And additionally, upload them in order. So you're going to notice there was 4 sets here, or 4 sections. Don't upload 4 first, and then 2, and then 4, or 3, and then 1. All right. Or anything like that. Do the first one first. It's just so much easier for me. As you look around, there's quite a few people in class. And so it just makes it more efficient for me to get through. All right. So this is number 1. So the first thing that I'm going to write then is going to be D is equal to V times T2 minus T1. So I'm going to start here. D is equal to V times T2 minus T1. Okay. Now, this is a lowercase v, and I always put a little tail on it. It's just what I do. I was also a physics instructor as well, and that v was also always like my velocity. It was the lowercase v. You don't have to put the tail on it. It's totally fine. It's kind of like just what I do for a lowercase v, but as long as it's the v. So now I want to solve for v. So this is my first, like, if you would, my equation in its original form. And now I'm going to be adding my work. Okay. Even if you're like, I know how to do that all in one, I want to see it, because remember, I didn't teach you your math. This is my first experience, and I want to be sure that, that there's not an issue. The worst thing that you could have in statics is where you're not ready for it. Okay. So this is my way of knowing you're ready for it. So I want to isolate V by itself. So that means it's multiplied over on the right-hand side here by T minus 2. And you'll notice that it's multiplied, right? So I always like to say, when I'm doing algebra formula rearrangement, I want to do the opposite, right? If I want to get rid of the T1 or T2 minus T1, If it's multiplied, I want to do the opposite. To me, the opposite of multiplication, and what is that to you? Division, exactly. They might not say that officially in math, but that's what I think of. So that means that to get rid of it on this side, I need to divide both sides by the T2 minus T1. So what I'm going to do is I'm going to put a horizontal line. Remember, any fractions are going to be up, down, not slash. And then underneath here, I'm going to do T2 minus T1. And because I did this division on this side, I need to do that very same division on that side, T2 minus T1, right? On the right-hand side, it's going to fully cancel out. And then now I'm going to rewrite this so that it's D divided by T2 minus T1 is equal to V. And then I'm going to put a box around my final answer. Okay. Now, I did some of my work in that original problem. That's okay. Or if you wanted to take the next line and do the work, either way is fine with me, as long as I see how you did it and I see the cancellations. You do need to do cancellations where they're appropriate. Okay. Box around your final answer. Questions about that? And make sure it's large enough for me, please. Sometimes I get people who write really super small, and then it's hard for me if I need to make any notes to, to make notes there. So be generous with the space. All right, let's look at number 2. Okay, so we'll go back over here. Number 2, we're solving for M. So capital M is right here. So we're going to start out by writing our original equation. So I'm going to take, so F times P minus A is equal to 2 capital M small m. Okay, so you don't need to say solve for M here. Just write your original equation, but you'll know that you're solving for M. So M is on the right-hand side, has the other things multiplied for it. So what we want to do is we want to isolate it. So since M is multiplied by 2, the first thing I'm going to do is I'm going to divide both sides by 2. So I'm going to add my horizontal line underneath, and I'm going to say, put my 2 underneath here. And then I'm going to go a horizontal line on the other side, and I'm going to put 2 underneath over there. I'm going to cancel out the 2 top to bottom here because I'm dividing both sides by 2. I'm going to do the same thing for the lowercase m. I'm going to put m down here, that canceled it out on this side, but then I'm going to add the m over on the other side. So now m is capital M, or uppercase M is all by itself. So now I'm going to write my final answer with a box around it in its final form. So this is going to be F times P minus A divided by 2 lowercase m is equal to capital M. Now, whether you put the capital M on the left side or the right side does not matter. Okay. Some people like to pull it back over to the right side because they like to have that isolated variable by itself on that side. Okay. But if you leave it where it was at, that's totally fine too. There's nothing, both of them are fine. All right. So this is what show your work means to me. All right. Any questions so far? Does that seem consistent with what you guys have done in math before? Hopefully. All right. And for right now, as we're starting statics, I am probably going to ask you to do a little bit more showing of your work, because then it just confirms for me that you're where you need to be. Okay. All right, let's do number 3. Okay. So this one we're going to be solving for R. So this is I is equal to, now here you're going to notice I have the asterisk. Notice that I had to do the slash just because I was working with Word and I don't have the ability or the know-how to make it top bottom. So when we write it out, it's going to be capital E plus E on top. And then we're going to put the capital R underneath. So this is how you would write this out to start the problem. Do not do the slash there. And that's what those 2 asterisks kind of, reference that note above. Okay, so we want to solve for capital R. So this R underneath here. So you'll notice it's in the denominator on the right-hand side. So we need to get it to the numerator, right? Or we need to get it up on top. So to do that, I'm going to multiply both sides by R, right? So I'm going to go like this on both sides. On the right-hand side, it's going to cancel top to bottom here. And then I'm going to end up with R times I is equal to capital E plus lowercase e on the other side. I guess you wouldn't need parentheses then, right? Technically. But now I need to get capital R by itself. So I need to divide both sides by I. So then they can cancel on this side. And my R is going to be equal to E plus E divided by I. If you want to keep the parentheses around the capital E plus lowercase e, that's totally fine. All right. Isn't this fun? Get to do this. If you are right now, this is so easy. I'm actually bored. That's exactly where I want you to be. Remember that. Okay. For this, I want you to be bored. I will challenge you. Don't worry. I'll keep you busy in statics, but for right now, this is good. All right. So now I've kind of gotten to the end of my paper. I have room over here for problems like this. So what I'll probably do is I'm going to go up here and I'm going to say, okay, number 4. Now, if you want to go to the next page, that's totally fine. Or if you want to go over and back, that's totally fine. Just make sure that you're numbering and that they're somewhat in an order. Okay. So number 4, we're going to be solving for H here. Okay. And this one is P is equal to B times H times 1 minus A divided by 2D. So again, we have to do top bottom here. So this one, let's see, it's going to be P is equal to BH times 1 minus A on top divided by 2D on the bottom. That makes sense. So here's a parentheses, kind of added an extra parentheses just because of the nature of how I had to draw it. So make sure that it's like this. And then now we're going to be solving for H in this one. Okay. So here, H has got a bunch of stuff around it. So I'm going to probably do this in a couple lines just because. So I'm first going to get the 2D out. So I'm going to multiply both sides by 2D. So I'm going to go 2D on that side. So when I do that, it's going to be 2 times D times P is equal to BH. And then, oops, add my 1 in here. 1 minus A, right? Now H is still multiplied by B. So I'm going to divide both sides by B. So I'm going to put B on the bottom here. It'll cancel out there. And then I'm going to add B over here. And then the same thing for the 1 minus A. So I'm going to multiply 1 minus A over here and 1 minus A over here. They cancel out on the right-hand side. So my only one uncanceled is my H. That makes sense to everybody. So now my final answer is going to be 2DP on top divided by B, 1 minus A is equal to H, and my box goes around that part. All right, questions, anybody? Now, if you haven't done virtual with me in any classes previous to this, what you're going to expect to see is you will see whatever's on my screen up here. And that's why I kind of sit right here. Okay. You're going to see whatever on my screen. So whether that is Canvas open, if it's doing the work like this, and then you'll always hear my voice in the background. Many of you have done the virtual option. So you in previous classes, so you kind of know what that looks like. So, so again, if you're comfortable with that and you feel good about that, this would be exactly what you would see. Okay. All right, let's do number 5. Number 5. So number 5, we're going to be solving for L. So we want to first write our equation. So again, I'm going to have AL and then we're going to go over top down or up, down, top, bottom. And then I'm going to have K times B1 plus B2. So that's going to look like this. And we want to solve for L. We want to solve for L. So I'm going to get rid of H first. So that means I'm going to multiply both sides by 8. I'm going to give myself a little bit more room. I'm going to call this 5 like that. So I'm going to multiply both sides by H. And H is going to sneak in over here. Okay. H's cancel on this side. So I'm going to rewrite this line just because I don't have a whole lot for anything else. If you wanted to do a little bit more work there, it's okay. So this is going to be KH times B1 plus B2. And I just put the H out front because typically that's where you're going to see kind of that formatting, right? If you would do it after, it's really okay. Doesn't matter which way, which order we do these in, as long as the parentheses on the inside are there. Okay, so now to get rid of the A that's along with the L, we're going to divide both sides by A. So then they'll cancel here. And my final answer is going to be L is equal to KH times B1 plus B2 divided by A. And that is my answer. Box around my final. All right, go ahead and do number 6. So here we're seeing the slashes. So just make sure you do your up, down, and then in this one, we're solving for R2, which is down here. So I'll give you a second to do it, and then we can compare in just a minute. All right, I'm going to start doing mine if you want to compare. So I want to get R2. So first things first, R2 is in the denominator on the right-hand side. So in order to solve for it, it needs to get up on top, I say, or in the numerator, right? So to get it out of the denominator here, I need to multiply both sides by R2. Okay, so that means it's going to cancel out, and make sure you do that cancellation. And now I've got, I'm gonna rewrite this, R2 times E1 squared over E2 squared. And that's going to be equal to our R1. Okay. So I did remove the parentheses there so that now we can see that R2 shares a spot on top, if you would, with E1 squared. All right. So now I want to get R2 by itself. So for E2, I'm going to multiply both sides by E2 squared, the full quantity. So it's going to take care of that. And that means I'm going to multiply times E2 squared on the opposite side. And then because E1 squared is in the numerator multiplied by the R1, that means I'm going to divide both sides by E1 squared. And like that, and cancel that out. So now R2 is by itself on the left-hand side, and then the rest of the variables are on the right-hand side. So rewriting it, R2 is equal to R1 times E1 squared divided by, I'm sorry, E2 squared is on top by E1 squared on the bottom. Yeah, watch your little like subscripts and such, because yes, when you've got squares and ones and twos, it's want to make sure it's correct. Okay. Let's keep going. Number 7. That one's at the top of the next column here. Go ahead and do number 7. So h squared is equal to d plus t, and we're solving for h. Now this time, You'll notice that our h is already in the numerator, but there's a square on it. So it's not by itself yet, right? Because it's h technically times h. So how do we clear a square on one side? What do we do to the opposite side? Take the square root, right? That would be its opposite, okay? So yeah, so since we have h here, that means that h is just gonna simply go to h, but then I need to make my square root symbol. And the square root needs to be over the entire right-hand side of the equation. Don't stop this short. So do not like go like this d and then plus t. It has to be of the entire right-hand side. Even if you want to put this in parentheses, that would be okay too. I always add this little tail at the end to show like where it ends. All right. Do you have to do that? No, not necessarily, but it definitively to me says it goes that far. Okay. So that's your answer. Box around that one. Let's do number 8. This one we're solving for t. It's t squared in the denominator on the right-hand side. So make sure you're writing this in that up-down format. 2k is equal to d and then over t squared. So this would be your start equation. So go ahead and solve it, and then I'll wait a little bit and we'll look at the process. Okay, we first need to get t like up on top in the numerator. So right now it's in the denominator on the right-hand side. So I'm going to start by multiplying both sides by t squared. Okay, so it's going to cancel it on the right-hand side, and we'll end up with t squared. 2k is equal to d. So now I got to get rid of 2 and k, right? So I could either keep those parentheses around it and then just do it at once, or we can just say, okay, I'm going to make my denominator, I'm going to divide by 2, divide by k. It's going to cancel out each of those on the left. And then I've got to do that very same thing, 2k on the right-hand side. Okay. Now, I don't have much room left down here. So I'm going to do my next step in this very same line. So right now I've got t squared is equal to d divided by 2k, right? So I'm going to do that very same thing we did on the last problem, where we're now going to take the square root of the right-hand side, the opposite side. So I'm going to just, cancel out my 2. And I'm going to start here at the bottom. I'm going to make sure that my square root covers from the bottom, the denominator, all the way up to the numerator, and then encloses everything here. It would not be correct if you had d over 2k and you went like this. That is not correct. Okay, do not do that. It's the entire side. So you have to make it, a tall square root symbol here. Okay, so my final answer is going to be t is equal to the square root of d over 2k with everything enclosed in a box around it. Okay. You might say, are you really going to mark off if I show something like this? Yeah, because it doesn't look like the entire portion is under the square root. It only looks like the top portion is under the square root. So I do look for those things. And they're not the same. Not the same. It's not equivalent. If you just take the square root of the top and not the bottom, it has to be the entire right-hand side. All right. Any questions so far? Aren't you excited to do this homework? Like, totally got this. All right. We just did number 8. So let's look at number 9. So go ahead and set that up. So we've got 2c over r is equal to AR over W. Now you'll notice there's two R's here, so we got to get them together, right? So I'm going to multiply both sides by R. So the left-hand side and the right-hand side. It's going to cancel the R out on the left-hand side. So I'll be left with 2C on the left, but then it's going to multiply on top here, right? R times R. So it's going to be A R squared divided by W. And now it looks like the other problems we looked at. And then we can isolate R by itself. So continuing on here, I'm going to get rid of my W first. So I'm going to multiply both sides by W. Okay, so my W cancels on the right. And then I need to divide both sides by the A. So my A cancels out. So before I deal with my square, I'm going to write out it's always good to put your number before everything else. So I'm going to do 2WC. If you do W2C, it's okay, but kind of like the formatting in terms of like what you normally see in math, usually you put your number and then any variables after it. So I'm just going to pull that 2 out front. Doesn't matter what order you really multiply these in, they'll be the same. Divided by A is equal to R squared. And then to clear that square, we're going to take the square root of the entire side. So again, writing this out in its final format, it's going to be 2WC divided by A, all underneath the radical, included, top to bottom, is equal to R. Okay. All right, we just got a couple more. So go ahead and do the last 3 problems. Okay, and then we will compare. And like number 11, it's EI, not E1, just so you know. So if you're working, I did do number 10. You should get P minus 2L divided by 2 is equal to W. Any questions on that one? Okay. I'm gonna do number 11 here. Now, these are the ones, and this is where showing your work is really important because you can usually catch these things just in case. The easiest thing to miss when we're doing math problems is like negatives or positives, right? When you move from side to side. So writing it out works to your advantage for this kind of stuff. So this is one of those types of problems. Actually, these last two. So I need to get P1 isolated. So since it's P2 minus P1 on this left-hand side, I need to take care of P2 here. Now, out front, assume there's a positive in front of there, right? When there's nothing there. So that means to get it, removed from my left-hand side, I need to subtract P2 from the left-hand side and do that same thing on the right-hand side. So these two will cancel, right? And now I'm going to end up with a negative P1 is equal to E minus I. Or I'm sorry, E times I minus P2. Okay. Now, am I done? No. What do I need to do here? Clear my negative, right? We don't leave something I'm solving for as a negative value. So to clear this negative, I'm gonna multiply both sides by a -1, right? Or I like to say, if I change the signs on one side, I got to change all of them on the other side, right? So if I make this positive P1 over here, that means that E times I becomes negative and P2 becomes positive. Everybody see that? Everybody catch that when you did it. All right. It's multiplying both sides by -1, right? Now, typically, the better way to write this would be P1 is equal to, and I always want to lead with my positive number. If you don't rearrange this, that is never going to be marked wrong, but it's how you're going to see it most often. So we would do the P2 first minus EI on that right-hand side. If you want best practice, if you leave it like this, I will mark that okay. I'm not that ticky-tack. All right, but you don't leave the negative as the P1. You're not done. You don't want to do that. So that same thing, did everybody get this? Any questions on that? So same type of process for number 12, right? So if we go up to the top, number 12, we're going to be solving for R2 here. So to get rid of H2, we're going to subtract H2. There's that positive out front that's going to take care of these, but we got to do that same thing minus H2 on the right. So now when we look here, we have a negative R2. So this is negative R2, bless you, H2. And now to make that positive, I'm going to make this positive on this side. And you can do that. You don't have to worry about, multiplying by -1. I'm going to make it positive, but then I have to change the signs to their opposite value on the right-hand side. So anything that was negative on the right-hand side becomes positive. Anything that was positive becomes negative. And I don't know, there's something in me. I can't let it like that. I'm going to put my H2 first minus my V2 and then put my thing around it. But again, if you stop here with a problem like this, that's fine. As long as the variable that you're solving for is positive. Okay. All right. The first 12 done. Practice problem. And look you're done with this. So at this point, if we would be done with all the practice problems, you would literally take a picture of what you've got here and you would upload it. So there's nothing to do outside of class for practice problems. Okay. It's just my insurance that you've got a good handle on what I'm expecting. Okay. And it makes it more interesting for you. Can you imagine watching me and not writing this down while I'm just demonstrating rearranging equations? How boring would that be? So I'm making it fun. Or not. All right, so that's my first set. Now we're going to turn the page and we're going to work on the next set. This next one is 2 equations, 2 unknowns. So we're going to continue using our algebra here, but you're going to notice that for each one of these, for number 13, for instance, I've got 3e minus 8r is equal to 12. If I look at that one equation, there's 2 unknowns in there. And algebra-wise, I can't solve for that value. I can only have one unknown in an algebra problem, right? Or an algebra equation to solve for it. But if I have another equation that has the same two unknowns, all of a sudden, I now have a shot, right? So we are going to utilize what we call the substitution method. How many people have used the substitution method before to do two equations, two unknowns? Yeah, it's always one of them. Another one, it's like, what do they call it? It's like a matrices that they use where they have the columns and stuff. That's the other way that you can solve it, but I want you to do these by substitution. So let's look at the process that we're going to use, and we're going to start with our 13. So I am simply going to mark this number 13. You can start this with set number 2 at the top, okay? And I'm going to write my first equation. I'm going to call the first one number 1. So this is going to be 3e minus 8r is equal to 12. So that's my equation number 1. All right, so that's equation number 1. My second equation, number 2, okay, is going to be E is equal to 4R. Okay. So those are the two equations that I have to work with here. They're the two equations with the same two unknowns. And I want to find a value for E and a value for R. Okay. So now the first thing that we're going to do is we need to solve one of the equations in terms of the other. And in this case, we already have it. What that means is I want to get one of my variables isolated on one side equal to the rest of the equation. And I have that. So step number 1 is solving one of the equations, either number 1 or number 2, in terms of the other. All right. So I've got E right here is equal to. All right, so I don't have to do that step. If I didn't have this where one of the variables was on one side, I would have to do that. All right, and we'll get an opportunity to. So now what I'm going to do is, since I have that, if this is equation number 2, I'm going to go up to equation number 1, and wherever I see an E, instead of writing E, I'm going to write 4R. Okay, so my first step here in my problem is going to be using equation number 1. I'm going to say E or 3 times 4R. So notice that that's what I put. I substituted the value for E for what it's equal to, which is 4R in this case. And then I'm going to continue on. Minus 8R is equal to 12. So now at this point, I should only have one variable in my equation. And I do, right? Now I only have R in here. So now I'm going to do some of this math. I'm going to distribute this. So I'm going to multiply 3 times 4R. So that's going to be 12R minus 8R is equal to 12. Now, because these two are both R's, I can combine those, right? So I'm going to take 12R and I'm going to minus 8R. So that's going to be 4R left over on my left-hand side is equal to 12. And then now solving for R, I'm going to divide both sides by 4, right, to get rid of the 4. And R is going to be equal to 12 divided by 4, 3. Okay. That's one of my variables. Any questions with that at all? Cool. This is going to come up. So that's why we practice it here. We'll have lots of opportunities in modules coming up that we'll get to use this. Okay. So now I want to solve for, I've got R taken care of. Now I want to solve for E. Okay. Now I always like to do myself a favor and I like to look at it, you know, what's the easiest equation? So if I use number 1 to solve for R, then I've got to substitute my value for R in equation number 2. Do you see that? I can't use equation number 1 again. I've got to use the other equation. So this 3 is going to go up into this equation right where I see my R. So step number 2 then is going to be substituting my value for R into that second equation. So I'm going to go to equation number 2. I'm going to say E is equal to 4 times 3 because that's where R was, right? So now I just need to do E is equal to 4 times 3, 12. Now, can I do a check on this? Yeah. So the last step that you want to do, now you do not need to write this out. I'm going to tell you that this is a part that you don't have to write out. But what you do want to do is just even in your mind, Go back up here to the top and make sure that this comes out. So if I take E is equal to 12, this would be 36, right? 3 times 12 is 36 minus 8 times 3 is 24. Is 36 minus 24 12? Yeah, right? And if I do it here, 12 is equal to 4 times 3. Yeah. Okay. You don't have to write that out, but do that check before you move on. Because if the answers don't come out, then you did something wrong up here. Okay. All right. Any questions on this? We'll do some more to get you that formatting down. Okay, let's look at number 14. Same thing. We're in that same section, substitution method, 2 equations, 2 unknowns. So write your 2 equations, identify one as number 1 and one as number 2. So I'm going to use the top one as number 1 and the bottom one as number 2. Here again, don't skimp on space. Give yourself plenty of room to write this stuff because, yeah, otherwise if you try to squeeze it into a small little area, it's just going to end up being a mess and it's going to be hard to follow. Remember, this is open book, open notes for our unit assessments, and you get to use this, in that case. So you're doing yourself a favor by writing it out, nice and neat and orderly. So I've got number 1. Okay. So I've got my top equation called my number 1, my bottom equation number 2. It really doesn't matter which is which, but in this case, we do not have one of the variables solved in terms of the other, meaning I don't have one of the variables on one side. So the variable that I'm going to focus on, and for no other reason than H ends up being the first one in either one of these equations, I'm going to look at the first equation. So my step number 1 is going to be equation number 1, and I am going to solve this equation for H in terms of K. So that again means I want to get H by itself on one side of the equation. So I'm going to have 7H. I'm just going to rewrite the original equation plus 3K is equal to 12. So I want to isolate H by itself on the left-hand side here. So I'm going to first get rid of my 3K. I'm going to put it to the other side. So I'm going to say 7H plus 3K minus 3K is equal to 12 minus 3K. So I subtract 3K on both sides so that I get rid of it on the left. Okay. So now I've got 7H is equal to 12 minus 3K. So now what I want to do is I want to get rid of that 7. So I need to divide by 7 on both sides. So the 7s are going to cancel on the left. And I'm going to end up with H is equal to, now, this is where we have to do a little bit of math. So instead of leaving this, now some of you may be fans of the fraction when you solve problems like this, but most people, including me, don't like to deal with fractions, okay? So what I do is I do my division, okay? So I'm going to take 12 divided by 7, and that number is going to be 1.7143. Hold at least 4 decimal places when you do these problems. Do not round to 1.7 here. Hold 4 decimal places. Otherwise, this rounding is going to compound through it, okay? And you're going to end up with, some values that are, relatively close to whole numbers most of the time, or even fractions if you would. So hold 4 decimal places inside here. So that's the 12 divided by 7. Then I'm going to take 7 into 3, and that's going to be 0.4. So subtract minus, because there's a minus sign there, 0.4286, and then multiplied by K. So again, 4 decimal places here. Okay. And now I've got H in terms of K. I've got H isolated on the left-hand side, and I've got my other variable on the right-hand side. Okay, and I did that with equation number 1. Everybody following so far? So now we're going to go to the other equation and we're going to do a substitution. So since we used equation number 1 here to get H in terms of K, I'm now going to go to, it's kind of like you keep flipping back and forth. I'm going to go to equation number 2. I'm going to write this out. I'm going to say 5 times. Now, up here it's 5H, but instead of H, guess what I'm going to write? 1.7143 minus 0.4286K, right there. That's where H was, right? Plus 3K is equal to, I'm sorry, no. That's number 1. Sorry. We have to be at number 2. It's minus 14. I apologize. That's why we use pencil. Minus 14 is equal to 6K. So at this point, what we should only see in here is one variable. And that variable is just K, because then we know we're going to be able to combine later on. So now I'm going to distribute. Okay. I'm going to do my distribution and I'm going to get 8.5715. So holding 4 decimal places still, minus, so it's multiplying these two together, minus 5 times 0.4286K. So that's going to be 2.143. Oh, I must have one more decimal place. I cut it off. I got, unless it did. I tried to be really consistent, unless I just didn't hold it. Oh no, it came out to be 2.143, and that's going to be K. Minus 14 is equal to 6K. So now we're going to combine what we can. So on the left-hand side, we can combine the 8.5715 minus 14, right? So that's going to be a negative 5.4285 minus 2.143K is equal to 6K. Now we want to get the K's on the same side so we can combine those, right? So we're going to add 2.143 to both sides, okay? So I'm going to do a plus 2.143K. So that's going to cancel it out on the left-hand side here. But then I have to add it to the right-hand side, 2.143K. And now I can combine the 2 on the right-hand side as well. So that's going to be 8.143K. And then this is going to be negative 5.4285 on the left-hand side. So to solve for K, I'm going to divide both sides by 8.143, right? So it'll cancel out on this side. But then I'm going to have 8.143 on the left-hand side. So K is now by itself. So now doing that math, you're going to notice I'm going to get 0.6 or negative. Oh, wait, did I do something wrong? Negative, yeah. Negative 0.667 is equal to K. Did you guys get that same thing? So that's going to be negative, if you like fractions, negative 2/3 is equal to K. How are we doing so far? You guys get the same thing? Okay. So now we have K solved for, but remember, if we go back up to our 2 equations on the top, we actually need to solve for H, all right? So we have these 2 equations and we just used number 2. So we want to substitute our K back into equation number 1, but don't go all the way to the top. Remember where we solved for H here? And we rearranged equation number 1. We want to take our value for K and we want to put it right there. Make sense? Okay. So our step number 3 then is going to be using that H value is equal to 1.7143. So it's taking this one right here and just putting it right here. Minus 0.4286 multiplied by K, right? Multiplied by K, which is a negative 0.6667. Everybody see that? So that's that value right there. And this was equation number 1. So now multiplying those out, our A should come out to be, that's going to be a positive, right? 7 plus. You get 2.00033, right? You gotta get the same thing as I did. And that's what's gonna happen. So you'll notice I get a 2.4 zeros and 33333s, right? If you round too much too soon, you're gonna get numbers that aren't gonna be like to the whole number. So we can assume if we would have done the fraction method, it would have come out to be 2. Does that make sense to everybody? I just find that converting them to the decimals is usually just easier. If you like fractions and you're like, no, I can totally do that with the fraction method, I'm comfortable with it, go ahead. But otherwise, just hold 4 at least decimal places inside the problem so that you can see those whole numbers appear when they happen at the end. All right, so if we go ahead and we plug these numbers back in, are our numbers correct? So if I take 2 times my H and 0.6667 for my K, okay. So 2 times 7 equals 14. Oh, mine doesn't come out. It's like it should be a minus. Did I miss a negative value somewhere? Is that supposed to be? Oh, I didn't. Yeah. You know what? I didn't put the negative in front here. That's what it is. Because this is 2. So it would be 14 minus 2 is equal to 12, right? So that means we're good. We're good. Thank you. See, it can happen so easily. All right. Any questions on substitution method? You guys feel comfortable with that? Some people are nodding. Let's do another one. That's why we have a couple of them here. So number 15. Okay. Remember, these are fractions up, down. So we're going to start with our equation number 1, equation number 2. I'm going to do the top one as number 1, the bottom one is number 2. So remember to write them in their variable form. And I have the top one as number 1 and the other one is number 2, the second one. Now, neither one of these has one of the variables in terms of the other. So that's going to be our first step is we want to isolate one of the variables. Since B is first in the equation here, that's what I'm going to work with. Okay. That's a random. If you started with D, totally fine. All right. And usually I look at these 2 equations and try to decide which one looks like it's just easier to work with. And I'm probably going to look at number 1 and say, that one looks a little easier to work with. There's just fewer numbers, but it doesn't mean that it's wrong to start with either one or pick a different variable. So I'm going to start with looking at the first equation and solving for B in terms of D. Okay. So I'm going to first write it out in its current form. So this is number 1, B divided by 2 plus D over 3 is equal to 4. So I want to isolate B by itself. So the first thing I'm going to do is I'm gonna subtract D over 3 on both sides. Now, since it's D over 3, as we know, there's an imaginary 1 right in front of our whole number D. So it would be 1/3. Or if we take 1 divided by 3, it's 0.33333. So if you want to work with the decimals, that's what I'm going to do. Go ahead and insert those right now. So I am going to subtract D over 3 here. So that means this is where pencils are handy. So this is my step number 1, equation number 1. So I'm going to do a minus D over 3 with a plus out front there so that this one cancels on the left. And then I'm going to subtract it and I'm going to do 0.3334 decimal places with my D. So I end up having 0.5B is equal to 4 minus 0.3333 D, 4 decimal places. Now you'll notice here that I need to get rid of my B. So that means, or I'm sorry, the 1/2 to get B by itself. So I'm going to divide both sides by 0.5. So I'm going to cancel out the 0.5 here. I'm going to divide, which is really a multiple times 2, right? Or multiplication times 2. You can do it either way. So my B is going to be 8 minus 0.6667 D. Right? So this is having one of the variables B in terms of the other variable. So B is isolated on the left-hand side here, equal to everything else. All right. So now that we have this one, we're going to substitute B. Now, since we used equation number 1 here, we're now going to default to equation number 2. So our second step is going to be using equation number 2. And we're going to do 3 times. Now, remember, it's up here. Actually, notice it's 3/4. So I'm going to put 0.75 out front right away. 0.75 times B. Okay. So it's going to be times 8 minus 0.6667 D. So everybody know how I got that 0.75 there? In my original equation, number 2, it's 3/4 times B. So 0.75 times B. And now this is my B value, which is 8 minus 0.6667 D. And then I'm going to continue on. So notice that I have D over 6. So there's that imaginary 1 right here. So that's going to be 0.1667, right? So 1 divided by 6, so it's going to be plus 0.1667 D. So this is 1 divided by 6. Again, if you want to hold the fraction, go ahead and do that. And then finishing up, it's going to be equal to 4. So now we can distribute, okay? So we're going to take 0.75 times 8, that's going to be 6. Minus 0.75 times 0.6667, okay? So that's going to be 0.5 D. Confirm that. I've got it. I wrote these out. 0.75 times 0.6667. Yeah. Plus 0.1667 D is equal to 4. So now what that means is we can combine these two, right? Because they have the same variable in back of them. So I'm going to combine those two. It's going to be 6. And it's going to be minus 0.3333 D. It's going to be equal to 4. Now I want to try to get D by itself, right? So I've got to get rid of the 6. So it's a positive 6 out front here. So I'm going to subtract 6 on the left-hand side and subtract it on the right-hand side. So the 6 will go away on the left. So I'm going to end up with 0.333 D is equal to 4 minus 6, which is -2. Now, because I have negatives on both sides, Actually, I'm gonna add a 3 here, sorry, I'm gonna hold my 3 decimal places. Since I have negatives on both sides, I can make those both positive, right? And then now solving for D, I'm gonna divide both sides by 0.333. Okay, so my D is going to be 6. Dividing by 1/3 is like a multiplying by 3, right? All right, I'm not done. That's one of my variables. Now I have to solve for the other one. So since this was equation number 2 that I found D is equal to 6, I'm gonna go back up to the step before. Remember what we said B is equal to in terms of D? We can take and we can put our 6 right there. Okay. So now what we're gonna do is we are gonna say, all right, step number 3, we're gonna go back to equation number 1, but we're gonna do it where we did this rearrangement. So this is B is equal to 8 minus 0.6667, all right, times D. So I'm gonna put in parentheses times 6 because that's where the D goes. I'm substituting the value that I just found for D, which is 6, where the D was. So I'm gonna get B is equal to 8 minus, and if I multiply these two out, that's gonna be 4. So B is gonna be equal to 4. Now, before I move on, I wanna do that little check. I don't have to write out the check, but it's always a good idea to go back up to the top and at least one of the equations, plug these values in to make sure that it makes sense. Okay, so if I go up here, I know that my B is equal to 4. So 4 divided by 2 is 2, right? And then my D is equal to 6. 6 divided by 3 is 2. So 2 plus 2 is 4. All right. So again, don't have to write that out. Good check. All right. Questions. How fun is this? Got one more to do. And you get to do 4 more for your assignment. So you don't have to worry about not getting to do this again. All right. And do the next one on your own and then we'll compare? Or you want to do it together? Together one more time? Together one more time. All right, so write your equations out. So number 16. Number 1. After this problem, we'll take a break, okay? So that you guys can get up and walk around a little bit, and then we'll finish up after. Okay, so for this first one, we're gonna kind of look, we gotta do a little distribution and combining before we can really kind of like use this as our official first equation. So that's what I'm gonna do in step number 1 first, is we're gonna look at number 1 here, because notice we have a Y kind of in here, and then we've got a Y out here. So we are going to distribute the 4. So that's gonna be 4 times X plus Y plus Y. So that means we're gonna have 4X plus 4Y plus, equals 7. Plus Y is equal to 7. So we have an imaginary 1 out here, right? So we can combine these two. So it's gonna be 4X plus 5Y is equal to 7. And that becomes our actual equation number 1, right? We have to do that little bit of work first. So now with our equation number 1 and number 2 kind of in their, lowest or they're kind of figured out combined state, which one do we want to solve for one variable in terms of the other? Is there any one that you're like, this one looks easier to deal with? I think number 2 looks easier to deal with because it's the equal to 0, right? So I can just push 1 on the other side. So that's what I'm gonna do. So my putting 1 in terms of the other is gonna be utilizing number 2. Okay, so I'm gonna rewrite 5x minus 2y is equal to 0. All right, and I'm gonna just move my 2y over here. So since it's negative on this side, or it's a subtraction, it's gonna be added on the other side. So I'm gonna say 5x is equal to 2y, right? I add it to both sides. So this is gonna be an adding 2y, adding 2y. So the 2y cancels on the left. 0 plus 2y is 2y. So now solving for x, I'm going to divide both sides by 5. So my 5 cancels out here. I'm going to end up with x is equal to 2 divided by 5. What's that number? So I need a decimal. I'm not good at that. What is it? 0.4, right? Yep, 0.4 y. Okay. All right, now this, remember, was equation number 2. So if I solve for x in terms of y with equation number 2, I'm going to flip to the other equation. So my step number 3 is going to be using equation number 1 in its combined form. Okay, it's what we did after step number 1. So 4x plus 5y is equal to 7. So 4 times x. So instead of x, we're going to put 0.4y. We're putting this right here, right? Plus 5y is equal to 7. So now we can multiply this out. So this is going to be 1.6 y plus 5y is equal to 7. Combining those two, we're going to get 6.6 y is equal to 7. Or did I do that? Yeah. And then solving for y, what do we get? 1 and a 16th, so 1.0606. And that's y. Or I'm sorry, just a minute. All right, so now that we have y, now we're going to take this and we're going to, this was equation number 1, so we're going to go back up to the opposite equation. And we're going to do equation number 2, and we're going to put y in its place. So our step number 4 then, it's going to be x is equal to 0.4 times 1.0606, because that's my y. So x 4.2424. I'm looking at the wrong one here, that's why. All right, so now this one we're probably going to have to plug back in. So if I go up to my number 1, 4 times x, 4.2424 times equals plus 1.0 606 times 5 times. That's not right. Did you guys not get the right? Did I miss a negative somewhere? Is that right? Oh, I did 4 times. That's why, huh? So so it's 0.4 times 1.0606 equals 0.42. That seems, that probably. Okay. And then we say times 4 equals 3.69. And then 5 times 1.06. Yeah, now it comes out. Sorry, thank you. I multiplied at the very bottom. I'm so sorry, I wasn't on the screen. I multiplied my answer 4 times 1 point instead of 0.4 times. Okay, so then I was off by a decimal place, as Steve pointed out, and then once I plugged these two back up into, you know, really either one of these equations, I plugged it into this one. Now it comes out. Okay, there you go. And there you have it. Yeah, so make sure you put the right stuff in your calculator. And this is really a reason why I want to see your work, because it can be as easy as, oh, I forgot to put that decimal down there. And instead of multiplying by 0.4, I multiplied by 4. My work was all correct, and it was just a matter of a final answer. You don't lose much when that happens, okay? You maybe lose a half a point because of that. But if you have a wrong answer and I don't get to see how you built it, now it's hard for me to know where you went wrong. Did you go wrong at the very end? Did you go wrong in the middle? If you even got something wrong up here and it just translated through, but your process was good, you get a lot of points for that too. Okay, so I am very much interested in the process that you go through, and I want to try to give you as many points as possible. And that is going to come from my having the ability to see your work. Okay. All right. So that takes us to the end of our second set. So what we're going to do is we're going to take a break now. And when we come back, we just got these last two to do: converting units and rectangular components. Okay.